Good evening, my name is Musa Ganeo. Here is my presentation on IS 607 for CUNY School of Professional Study on my master's in data analytics. I'll be working on three different data sets. The first one was from the University of California website, and the second one was from the World Bank, while the third one was from the cancer.org United States website. Analysis was done on it. I saw on the first data set that the variables in question, most of the observation are really, really high. So I thought it would be great idea to be able to relate it with other data to be able to see what is really going on there and then what might be the reason why it is going out. So I'm motivated to even say this because the air quality throughout the whole was really, really high. So we some of them are really, really bad at this time of the of time. So we like to look at the impact and then to be able to offer solution. Here are the packages I'll be using for this analysis. Please, if you don't already have it, you are kindly advised to install it and then load the library. So here is a link to the first data set. If you really need it, you get it from the website here, or you might even want to get it from here. So the first one is our .slf file. So I loaded it on my system. Here's the dimension. As you can see, is over 9,000 observation with 15 variables. Uh, these are the variables. These are glimpse of the variables. And then here we could see that with details we have a lot of NAs there. So I was like maybe it will be good to be able to like change the NAs to zeros. So we thought it would be a great idea. They are missing values to change it to zeros, which we did right here. And again, the names here they are really ambiguous. So we thought it would be wise to be change the names to a real names. So I changed the column's name to that. Uh, as I said earlier, here I'll be working with Haru and as well as my SQL and MongoDB. So I try to connect this to be able to see from three different angles. Okay, so from here I connected it to my SQL using this code. Please, you kindly advise to change this to whatever you have as your own login details. So here I checked it to be able to see it really connecting, and then these are the lists on my SQL that's already had there before connecting. So here I try to drop any table that is already there, if it's already exists, to change it. I mean to drop it. So here I write it there that the new one will be named this, and then to list everything that contains in that. So here I try to write another table for future use here. So these are the attributes, the attribute information if you might want to know what CO is all about. So this is all it is. And then here, so as I said earlier, we'll be sampling it because the observation is really, really high. So we thought it would be very ideal to sample most, at least part of it. Here we sample like 900 observation out of the 9,451. That is less than 10%. So here we have it here. These are the structure, and then this is the summary. We could see here we have the minimum, the maximum values, and the median, the quarter, the first quarter, and the second, the third quarter right here. Uh, we try to access this using my SQL to be able to even see, based on the EP recommendation of 10 ppc of benzene in drinking water and consume or exposed to in here. So here we see that we want to know the those observation from benzene that is actually greater than 10. So this gives us that we could see that the benzene is really, really on the high side. So we thought of connecting it to MongoDB. A no relational SQL is a no SQL. So connecting it, and then we check if it is true. If it is connected, it tells us that it is true. If it is not, it will tell us also that it's false. So here is connected, and we see the database right on it. So we try to name it that, and then here it is. So the 900 observation was sent in today, and then it replied that it already got it here. So here we try to plot based on that to be to see what we have there, and then this is uh, what we have there as a scatter plot. There's a mistake there. And here we try to check if there's any correlation between the temperature for the air quality and the benzene. We could see that this is on the high side, right? There is really a positive correlation between the two here. And again, we went ahead to check if there is, to check the linear model between the two here, and then here at the summary. As you can see here, the p-value is really low. So here, give us that, and then the residual there. I mean the R square and the residual. So we're trying to plot these and using that to be able to see it well here. So what we got? So we are checking these to be able to see if it is normally distributed. Maybe it will be good to be able to use our linear model. So here we saw from earlier on that there were two observation, two va variables there, the date and the time. So we don't really need all those. So we're trying to subset that from all the remaining. And then this is what we got. And then here is the plot of what we have left. So now we'll be moving to multiple linear regression. So y is the dependent variables, and then these are the independent variables. This is the intercept. So we set up our hypothesis. The first hypothesis for the first data set is the population parameter means they are the same, and the alternative hypothesis says they are not. So we set our rejection decision here that if the p-value is less than the tabulated value, which is the table value, we should reject h naught, otherwise we do not reject. So from here, before we proceed with thinking it will be better to be able to do a model selection to actually see, because we have a lot of models, we have a lot of variables here. They might not be every one of them might not be really interesting. So we're trying to do a kind of a model selection, both stepwise, forward and backward selection. So here means both selection. So after that, so we see here, these are the really variables that's really ideal for multiple regression. So here is a summary of it. So we got a summary right here. We see the p-values here. We see all the p-values are really less than the table values here. So from here, but we don't really want to conclude on based on that. So we try to look at analysis of variance to be able to see before we be able to conclude. The same value is being given for analysis of variance, the degree of freedom, the sum of square, the means of sum of square, and all those. So this really gives us the mean value, which is really less there. So and then we're trying to look at the error time as well. So since the p-value is really less than the tabulated, we actually reject h naught, that they are really of the same they are not of the same mean. So we are going to check the distribution of residual with normal distribution. We're trying to compare the residual with the normal distribution as we got from there. So this is what we got here. So trying to compare the residual with the normal distribution. So this is what we have there, also there. So moving to the second data set here was the data was collected from the World Bank. This is the conclusion for the first data set. From the above multiple regression analysis and alpha, we found that the p-value is actually low compared to the table values. So we therefore reject H0 and conclude that there is or are differences between the variables. So the second data set was extracted from there. So we'll be using dplyr and some of the libraries as well. So here it is for the is of 178 observation. So we're trying to match it with the second observation to avoid bias. So that's why we will be reducing the first observation from 900 to 170. Like at least, I mean, I will be sampling 178 observation from it to be able to compare with this. So we sample out 178 observation, and then here we do a linear model of the temperature and then the annual temperature. We're trying to see if there is any difference between the two temperatures, the first one and the second temperature. So here it was done here, and okay, here. This is the decision. We therefore accept H now since tabulated P value is greater than D. So the that is, there's no difference between the means of temperature in one and temperature in two. So we are actually on the right track. So taking the third data set from here is the link to the third data set. So we set up the new hypothesis that there is no relation between benzene in data one and the average in data three. So here we read the data here, and then analysis was done on it, and then we trying to change some of it to numeric here. Here is a view of the table head here, and as you can see from here, if we actually go in here, we see that the data is being categorized here. I mean, it's being categorized for either stable, rising, or falling. From the side here, they actually explain what rise or fall is table is. For example, for Fairmont, we see that the trend is stable because the trend is minus 3.3 with 95% percent confidence that is going to be between this. So it is considered to be stable, and that's what we have there. So we're trying to like uh, separate the stable from the rising and then from the falling. So here is what we get there, and then we made a plot to be able to actually see them. So this is a plot for stable, and then we also have a plot for rising. This third one, uh, the observation from there was just for a state, so we didn't actually plot any table for that. So this observation was for 45. Uh, this data set was for 45 observation. So we actually tried to sample it down to 45. So we combine the column together here to do a linear model. So this is a linear model done on the third, the first, and the second data set. So as you can see here, after all those analysis, we see the p value is really on the high side. So we therefore reject H naught since the calculated p value is greater than the tabulated value. So we make a general conclusion that based on the above analysis done on the three data sets rather, we therefore conclude that there are strong relationship between the carbon monoxide, temperature, and benzene. Though the data set might not be enough to be able to determine the actual causes and link between the variables, but we are strongly confident that the reduction in the exposure to the atmospheric condition, that particularly benzene, may aid in reducing leukemia in the United States and the world at large. For the references, here I have the references. Thank you and God bless.